So, sequential logic circuits. So, we have discussed last week about SRLH and sequential logic circuit. We have discussed SRLH without the clock signal. And as I mentioned, actually create the memory, we have this clock signal as well. So by creating the clock signal, we can create this flip-flop. And today, we learn about JK&D flip-flop. JK&D flip-flop, which is some variation about this flip-flop. And by using JK&D flip-flop, JK flip-flop, we can create a binary counter. So binary counter is a circuit that you can count up to any number of values starting from 0 to that particular value. And then D flip-flop, which is for storing and reading a memory or single bit inside the memory. So those are built by using these D flip-flops. Right. So as I mentioned, combinatorial logic circuits are perfect situation for require immediate application of Boolean function by using those set of inputs. But sometimes when you need to change a particular value by considering the current state and node, then you need this sequential circuit, because to state that current state or remember the current memory or current values. So sequential circuits provide that functionality. So one major thing is when you are creating a such sequential circuit, you need this clock symbol. So I explained what is about last week as well. So this is the rising edge. So this is the clock falling edge, and this is indicating the high altitude of the signal. This is the low altitude. And the one cycle, this cycle considers as a clock tick. So the signal will only change where this clock tick is happening. That means in this rising edge, only that rising edge, the clock signal or the computer can change the state from current state to the next state. So by using two NAND gates, NAND gates or NOR gates, you can create the SR filter. Right. This is SR latch. Create the SR filter. You need to include the clock signal. So how you can include the clock signal. So this one is for the clock signal. It will be OR and this will be OS. R1 reset is being set. It's the third flip flop and the truth table is R Q and plus 1. That means the next state. So 0 0 1 0 1 0 1. So this state, as you remember, this state as it is no change state, and this is for reset for 0 and no change. That means we'll have the current state. So reset means we'll set to 0. This is set state known as set. So that means we'll set to 1. And we call it is invalid. Because by using this no gates, you see this value will be 0. And both Q and Q bar both are same, right? So it is by theorem, the first output should be Q and the second output should be Q bar, right? And since this both are getting the same value, so we consider this as invalid. Then even you draw this by using NAND gates, you can see this value will get 1. So it is dependent to the infrastructure. And so when we are using, we are not going to consider this state where both San are 1, right? So there is a problem for this particular state. Let's say we can change this to something like this. Since this is Qn bar, right? So our problem will be solved. For that particular reason, we the new flip-flop introduced called this JK flip-flop, JK flip. So this is the JK flip-flop truth table. So this is the way. In the JK flip-flop. This is our clock. So this is our start flip-flop, right? So you can do is then put another 2 AND gates, right? And this particular input is connected with this one, right? And this particular input is connected with this one. Here, this is our Q bar. And now this is called J and K. So actually, J, K. So in the block diagram, block You can simply say this is Q and Q bar. So this particular diagram, right, it is okay to write down in this way, but these you need if remember these terminology, right? Where S is 0, R is 1, so that is state is reset, and where S is 1 and R is 0, that state is the same. And then consider you have this case these are J and these are K. Right, this is the JK because this is the diagram. So and with the 0 0 and each the every state the clock signal is 1, right? Otherwise we need to consider clock as 0 0. So S and R also will become 0. How? Since this is AND gate, right? Anything comes from either 1 or 0, doesn't matter, right? So our S and R will be 0. Since this is both 0, the output is not going to change, right? Output is not going to change. So I will start. Let's actually replace with this block diagram. Then we see uh, so this is our clock. So I change this variable. The first one is set. So we need to change this one as well. This is K. Right. Both are 0 0. Our S and R will also 0 and 0. Down here 0 and 0. Right. So nothing, there will be no change. Next, the other thing. This is for 0 0. The other thing is 0 and 1. Right. Since this is 0, so anything comes from here will be 0. Right. Come from here will be 0. Right. These are 1 or otherwise. Right. Let's consider then this symbol is 0. Consider this the Q is 0. Right. If current Q is 0, then it's always going to be 0 for this particular state. Right. Then zeros S and R means there will be no change for this particular 0 and 1. Right. So that means Q is 0. Our previous Q is 0. And since this is 0, this will be 0. Either this is 1. So 0 0. So it means no change state. Right. So no change state means Q is 0 and Q bar is 1. Right. Now consider the other state where this is 1. Right? If this is 1, what will happen is for this value, this will be 1. Right? That means R is 1. Then what is this state? This reset state. Reset state means again Q is 0. Q is 0 and Q bar is 1. Right? So either this value is 0 and 1, there is no particular change. Right? So we can consider where J is 0 and K is 1 is the reset state. Right? So other state is 1, 0. This is 1, this is 0. So likewise, we can go from this one. Right? Go on this particular line. So obviously this will be 0. No value is going to here. So R is this value is 0. For this particular value, if this the value the Q bar is 1, there is two state. Q bar is 1 and Q bar is 0. If Q bar is 1, that is only where this value is going to 1. Right? Q bar. If the Q bar is 1, Q bar is 1, then only this is going to true. So S and R means actually the set state. So set state means Q is going to be 1. Q is going to be 1. And what will happen to Q bar is going to be 0, right? Do you agree with me? If this Q bar is 1, that is where only this value is going to 1. So 1, 0. 1, 0 is an output 1, 0 means is set state. Set state means where Q our current value Qn plus 1 will be 1. Then there will be a change for this one. Right? So then take the where this Q bar is 0. Q bar is 0. Then Q should be 1. Right? So what is happened is now in the no change state, right? It's 0 or 0, no change state. So no change state means there will be no change. So that means Q bar was currently 0 and is going to not change. And Q is 1, it is also not going. So you can see either Q bar is 1 will going to reset to 0 and Q will set to 1. And if the Q bar is 0, then there will be no any change. So in either case, our next Q is 1 and Q bar is 0. So that means the set state. Right? Now the major thing. Or the final part, where X and R got the equivalent. That means both are 1 now. So what will happen here? Both are 1. Right? Then consider. So there are two states where this is 1. So you need to consider the previous state should be a valid state. So that means if this is 1, then this is 0, and this is 0, then this should be 1. So this is the previous state. That means Q8. Right? Consider this one. Right? So only here it is going to 1. And for this one, what will happen? 0 and 1 will be 0, right? So what should be the output? 0 and 1 is reset state, right? Right. So reset state is Q is 0. So currently what is the value? Q is 1, Q bar is 0 currently. So now trigger the reset state. So what is the value? This will change to reset means Q is 1, Q is 0, right? For this one. Then let's consider this one. Right? So this is 0 and this is 1. Now this where it will occur 1, right? And this where it will occur 0. So 1 0. 1 0 means set state, right? So in the next one, this value is 1 and this value is 0. So now it is set state. So set state means Q should be 1 and Q bar should be 0. Set state. So you can see it's going to change the value, right? Change the state. So that means if Qn is Qn is 1, Qn plus 1 will be 0. If Qn is 0, Qn plus 1 is 1, which is actually the current previous Qn bar, right? So we can see if Qn plus in this particular state, last state, it will going to change the value, right? Change the previous state. So in JK flip-flop, it will change the state in this one iteration or one both input value is 1, right? So in JK flip-flop, we can fix that issue, merit issue which are having in the SR flip-flop. And by using this JK flip-flops, we can create a binary count. So what is a binary count? So binary counter is a logic circuit. It's a sequential logic circuit where you can count from 0 to particular value. So let's say if you here we are only creating considering about 1 bit, right? So you can create the 3-bit circuits. So from 0 0 0 to 1 1 1. So this value is 0 and this value is 7. So up to there will be 8 tokens. And if you consider 4 bits, so this value is up to 15. Right? Likewise, you can move up to any particular value. So I will create a 3-bit binary counters. So block diagrams. right? So here I'm going to only consider our Q. Right. So we connect these every props in signal one signal like this this line you can call the props. Right. Be our bits zeros bit 0 bit 1 and bit 2. Right. So please be careful. So here I'm going to start and then this connected to here and we need to take the bit 0 output to connect with every only the dot points where the connection is happening. Right. So after that, okay, this and finally uh, both of these outputs get the output. So this is the 3-bit binary counter. In your exercise, there will be a 4-bit binary counter. So let's consider what is happening. So here we can enable the name. This is the way we can enable the counter, right? If this is true, then in each clock pulse, each bit patterns is going to change, right? So consider this all are in the reset state. So that means value is 0, right? So JK is be 0 state, right? 0 state, and here also it will be 0. And from here, so these two will be also 0. So out of an AND gate also 0, right? And gate also 0, and since this is also 0, this J and K also 0. So all will be likewise zeros initially, right? Now I am enable this. Now the 1 will pass, right? 1 will pass. Since the consider clock signal is in 0 state initial, so that means either 1 pass, there will be no any change, right? From the initially, very first initially, there will be no change. And consider the first clock tick is happening. First clock tick is happening, right? right? Now, the previous inputs are these 0, 0, 0. Now only the clock first tick is happened. So what is the output for this one? For this particular case, so it should be, since this is both the ones, right? This value should be changed. So what actually happens in binary counter is it will keep adding ones. So initially it was 0, 0. If we add 1, what will happen? 0, 0, 1, right? So we are adding 1 again, right? So if we add 1 here, then what will happen? This value will be 0. So 1, 1 means 1, 0, right? So we are adding 1 to here, right? So this is the first stage. And second stage, now we are in the third. So that stage means we need to add 1, right? 1, 1 is 0, and 1, 1, 0 is 1, and 0. So third stage is 1, 0, 1. So both state are 0, 1, 1, right? So next state, what it should be? We need to add 1, 0, 0, 1. So this is the fifth state. 6, 1, 0, 1. 7, 1, 1, 0, 8, 1, 1, 1. So this is the operation which will happen underline the binary counter, right? So now consider the first floating happen. That means 1. So this is 1, this is also 1. This is also 1, this is also 1, right? In the first initial floating, right? Since this is 0 initially and this is happening, we need to change this particular bit to 1 because q bar is 1. So at small time before this value is 0, and now what will happen? Now it will happen, it will be 1, right? But what you need to keep the idea is this is the current value. Now again the present value, right? But what is the output or the input for these ones? Hmm. So this one, right? Clock tick is happened, right? And change to this one to 1. But what is the input for this one? This is actually qn plus 1. But here we need to input qn. The reason is the time before this is happened, this whole particular line consists of 0. Only after this particular line, the next immediate next will be changed to 1, right? But it's not going to change this output. So here it is 0, right? So since 1 is 1, 0, this is 0, so whole thing will be 0. So from here onwards, the whole thing will be 0 for here. Since 0, 0 is not change state, so here also output 0 and here also output 0. So 0, 0. So those are in no state, no change state for the first initial occurrence, right? So after that, this is on the first tick. Only change the value here, right? Then after that, the next tick is happened here, right? Then what will happen? Now is it 1, 0, 0. Yeah, you can argue that uh, this also should 1, and the uh, since after clock tick happen, so clock tick means this is rising, and there are several stages, right? You consider a particular property. What will happen to this time period? So that is what you need to keep an idea. Are only the values are going to change where the X rising is happened. So when the X rising happened, to draw the timing diagram for this one, both J and K were high. So 1 0, this K 1 0. So both J and K were high, and our Q is lower when the first edge rising happens. This is our plot, right? This was the state. Both these were high. J and K were high, and the right again this way, right? Here the properties happen, right? So Q. So in this case, these are ones, and our older Q is 0. So it's not going to change in this, like the next tick is happen. So, so this is the place where the next tick is happen, right? For this particular flip flop, I have do the timing diagram. So from here to here, sorry, since this is 1, there will be a change, right? So this is 0 and this is 1. So from here it will go to change, right? To here. For this particular period, the Q will be 1, right? And right. So Q will be 1. So Q0 is the B1, right? And BTUs. So you know QB0. This is what happened QB0. Let's consider QB1. What will happen to QB1? Right? Or initial property. Right? So in initial properties, you know this was 1. And when the initial property happened, before changing this value to this 0 to 1, so changing this value, right? QB1 was 0. QB1 was 0, and this line also 0. So in that particular case, what is the value here? Is 0, and it's going to pass 0, 0. So J and K for this term 0. Will be zeros, right? So this clock happening. So J B1, A B1. So those were 0, 0, right? Those are 0, 0. What will happen? 0, 0. So will in a no change state, right? These are 0, 0. 0, 0. So it will not change. Yeah, Q is remain 0. Here also it will happen the same. So this is the initial tick, right? So after that, where next tick happened, right? So this is the uh, current state before the happening. Now it is happened, right? Next tick is happened. Now where next tick is happened, you can see this QB0, 1. QB0 is 1, right? Next tick, when next tick happening, there will be 1. So this is 1, 1. There will be 1. So you can see after only this happens, these values will be become 1. So I need to redraw this one again. So initially it was zeros, right? Initially it was zeros. After that tick happened, right? This is going to 1. So after that one, our JB1 and those will be 3. Those will be 1. The tick happened. So after that one happened, till this one happened, our J1, this one and this one becomes 1. But after the tick happened, right? After that second tick happens. First tick happened. After the first tick happened. So before first tick happened, those were 0, 0. That's why actually when you are drawing the uh, timing diagram, right? This is the clock pulse, right? So there should be some fraction of the wave a bit early to indicate what is the value actually before, right? J, usually you need, maybe there something, some small fraction is bit ahead. So if it is not the case, and it is like something like the change is happening the same time, right? So to happen this change, what are the values are taken? These one, 0 and 0, right? So that's the small thing that you need to keep aware of, right? Otherwise you are going to be confused. So this value change happening when the tick is happen. So uh, I don't know, is that ඒක සර් අපි සෝල්ව් කර right? So now we are going to consider the second tick is happened, right? So here the second tick happened. Now our QB0 is in one state and these are one off, right? So in this particular region, it should be changed to again because this is 1 1. So previous value is 1. So it should be changed according to this particular value or particular state in the truth table, right? So now this is 1. This is 1. So our QB1, this one, they should also change. So here the value is 1, 0. Now it should change to 1, right? So this should change to previously it's 0, 0, 0. And then in the very first tick, change to 1, 0, 0. In the second tick, this value will change to 0 and this value change to 1. So before that, this particular value was 0 and this value was 1, right? So in that case, false or 0. So in that case, this is 0, right? So it is 0, 0. Likewise, in this state, you can draw the timing diagram and see. So this is 0, 0. So this value will be 0, right? So, after this particular tick, the whole one will be going to stay, right? The ones. No, actually, no. Oh, right. So this is changed to 0. This is changed to 0 to be 0, right? Here it is changed to 0, right? So when the next tick is happen, right? So this was 0 and this should be 0, right? So you can see after this one, this value is going to 0 again, right? So here it will go to state 1, but here when this is changed, so immediate next it will be changed in every state, right? So you can go through it each one. So now it is 1. So next particular tick, right? So this will change again to 1 and it's still going to stay in the same because it will now get 0, 0. So that means no change. Here now only the here will get the ones. So likewise, again this is going to change. So you're going to stay. Now here also it is will be 0. Right? And now it's going to change. Right. So you may wait, you can go through this value will change to 1, 0, and 1. Next, what will happen is will be 0. This is 1. It's going to stay 1. So next, say going to 0, 1. It's also same 1. It's also same 1. So you can see it's the first, the second, third, fourth, fifth, sixth, seventh, and eighth. These 8 occurrences. right? So it is the binary form. So please go through it, drawing the this timing diagram and all to see actually what is happening. So you need to keep an idea. Only this happens. So you need to consider the immediate step before the before value, this value you need to consider, right? Only that occurrence, the value is going to change. So the next topic is the flow. So it's very easy. So the flip-flops are used to store only one particular bit. So this is the fundamental circuit for computer memory. So it is also another sequential circuits, right? So I will explain you about how to create this deep flip-flops using NOR gates. So you need to be aware how to draw this one using NAND gates also. Right. So say this is yes, it's up, and this should be Q, our Q bar, right? And one of those and grade to use the clock. The major difference is for this particular gate, right? This particular gate actually don't have a clock. The flip-flop don't have a clock, and this where where we do the clock signal. So this particular line will match the read-write line or read-write signal, right? And we actually ignore this Q bar. We don't need actually the Q bar. We only need the Q. And the things this is a flip flop, a SR flip flop. The problem was what 0 0 1 0 1 1 0 1 1. So this particular line where it happened not change. So we can remove this 1 1 occurrence as I mentioned by using what we done in the JK flip flop of simply by using a not gate, right? So what that means is, so in the flip flop there will be one output, so that is called data in, right? Data in is called D, and if you will represent that data out. So this is the read write. So what that means, if this is enabled, then actually then only we can write. This is 0. That means this is flip flop in the no change state, right? So you will deeply keep stream in the current state, right? If this is 0, then this both will be 0, 0. Then it is in the not change case. So data in means only here we are giving our data. So data means it is either 0 or 1. But that means we can store 0 here or 1 here, only one bit, right? So let's consider we want to store 0. Now we are in store 0. So that means this particular line is 0, right? So as I mentioned, this is still 0. So that means the this flip flop in the reading state. So 0, that means this is also 0, this is also 0. So in AND gate, so will be 0. So it is in the not change state. So that means if this flip flop so there are going to our clock signal or read write. So clock actually the read write and our data 0, 0, 1, 0, 1. So in both these cases, you say t plus 1, right? So both these cases where clock is in 0, so will be our clock the previous output, right? No change because that are both are getting 0, 0, and if this so let's say that q is 1, so output is 1. If it is 0, the output also 0. That means no change. So if we need to write something, that means we need to write a particular bit to inside here. It should be either 1 or 0. Change in value or change the same. So how we can do that by using the set and reset states. So in order to do that, we need to change this to write state by enabling this 1 to 1. Now the whole one over this line P1. Right now this particular data or the flip flop is the writing state. Now consider the power bit is 0. So what will happen? Both are 0, 0. Right? Only this one. Since this is 0, so I forgot in the previous like that still this still this particular one. This is 0. It is this is 0. This then this is 1. If it is 1, this is will be 0. Since the blue is not here, right? So now it is in 0 state. This line is 0 state. Then it means this will be 1, 1. Or this line is 1. So 1, 1 means this is 1. So 0, 1. 0, 1 means is what is the preset state. So that means the value is 0. Right? And it is 1. The value is 1. Right? That means this is 1. And this is 0. This is 0. And this is 1. So 1, 1 means this will be 1. And what will happen? 0, 1, this will be 0. So what is this particular state? So it is in the set state, right? So that means this will change to 1. It change to 1. So if we enable the writing, then we can using the set state we can write the particular bit to this circuit or this D flip flop. So as I mentioned, you need to enable this to write the particular data. After enabling, so by using those set and reset state, we can store a value. So look that. So as I mentioned, there will be only one output we are considering this Q and data. And what is the clock signal. Enable read and write. So this is the clock flag. So this is the data in. This clock is for read and write. And this Q is our data out. So computer machine register. So register is, as you remember, it is the more fastest memory available in the computer. So the register is created by using these D flip-flops. How? It's considered a 3-bit register. So there should be 3 D flip-flops. Right? So the so Q data Q Q is the clock. And these are input lines. So we have output lines. So so 0, 1, 2, so 0, and the block tag is the register. So there are several inputs. There are several outputs. So inputs and outputs should be equal. I1, I2, 3, I4. Then this should be 0, or 1, or 2, or 3, or likewise. And about the computer memory. So memory can store many bits independently. So register bank containing many flip-flops. And in the memory, you need to identify. So actually, memory need to identify what are the flip-flops. So what are the bits that we're going to read, and what are the bits that we're going to write. Right. So memory need to identify which bits, which write, read, or write. So how to do that? We can give unique address to each bits to identify whether those are in a reading state or writing state. Right. So if you search through more about this, so addresses. So addresses, there are several number of addresses in the machine. So those addresses will pass to the decoder. So from the decoder, it will identify what are the addresses that are in reading and writing state, and they will only enable that particular flip-flop, right? So decoder means there are n inputs and 2 to the power n outputs, but only one will be enabled, right? So that means let's say we have 4 flip-flops, that means 4-bit address. So each bit or each circuit has a memory address, and if we need to store a particular value for a particular memory address, so how we can do? We can pass the informations to decoder, and it will enable that particular memory address, right? So let's say 4, then we need to output. So let's say we need to store the third flip-flop. So address number 2, let's say I'm starting 0, then 1, then the 2. So it will be the third flip-flop. So what we need to pass that particular value. That means we need to only enable that particular line, right? We need to enable that particular line, right? How you can do that? By passing the clock signal, right? Using the decoder. So decoder, so that means is every clock signal connected to a decoder, right? So let's say is 4. So this clock signal also connected to this. So there are 2 outputs. So we need to indicate this one, what you can pass the number 3, right? Oh, that means C0 is 1, 2. So 2 means 1, 0, right? 1, 0. If you pass 1, 0, we'll enable only this particular line. Enable this particular line. So all other lines will be zeros, right? So we pass the data. Right? Consider we are passing data. So now solve some, let's say 1, maybe 1 no 0, maybe 1 no 0, but only going to write for this particular address because only here the clock signal is in the writing state. So in every other is in the reading state. So in this way, you can write to a memory, even for reading as well. What you can do, you can, so for reading means, so there are 4 outputs. So you need to, let's say you need to select this one, right? Well, how you can do? Table multiplex, right? So by using the control lines, you can select the particular output. So in this case, you can read or get the data out. Right. So this is the end of the digital logic part. So here I mentioned how the memory is actually working by using those decoders and multiplexers also. And if you have any questions, you can email me, and yeah, you can contact me to resolve those problems. So thank you, students, and if you have any kind of problems, please let me know. Okay.